Okay, but why?
Hi everyone, and welcome to today's episode of OK But Why, where I finally give you the answer to the thought experiment that I had shared with you 2 weeks ago. Now, for those of you that haven't seen the video, I posted the link in the description, and it's only about a minute and a half in length, so you can take a quick look at it, try out the experiment yourself, and then come back over here to find out the answer. Now, I did get quite a few emails with fascinating answers, to be honest, and it was really interesting to see what lengths people were willing to go to just to get my little charger a little support. I really appreciated you guys. Now, if you're wondering which one of them got the right answer, then I must tell you that there's more than one right answer to this problem. And in fact, I received many correct answers. The simplest one was, of course, using a large fan that would blow air upwards to support the charger and have it floating in air. Now, like I said, that isn't exactly wrong. And in fact, the common thing about most of the answers I received is that everyone was trying to find an additional upward force that would support the charger against the downward gravity. Now, this idea of a supporting force is interesting, really, and it's really helpful, just like how you can support my channel by clicking on the subscribe button beneath this video and sharing this video with your friends and family. But the answer that I am about to give you can accomplish this task without involving any additional forces at all. And so, the key to defying gravity without using any additional forces is spinning the charger. Yep, that's as simple as it is. Just spin the charger. Because when you do that, you realize that every time it hits that vertical position, the cable doesn't bend at all, which is exactly what we wanted. But hold on, surely you want to know why that works. What type of additional forces does spinning introduce into the situation that seems to solve the problem? Well, the secret to that lies in the cable itself. So, if I hold the cable stretched out, then I'm sure you'll agree that it tugs on the charger a little bit. And of course, when I hold it this way, that tugging or pulling force acts downwards. Which is why when I hold the charger still at this position and I let it go, it gets pulled down. But when I move the charger at right angles to the cable with a particular speed, then this pulling force transforms into a tethering force. And we all know what tethers do. They make you sweep out the arc of a circle. And the only thing that causes this pulling force of the cable to change into a tethering force is the movement of the charger itself. So this is a fine example to show you how sometimes all you need is a little bit of movement to change a lot in your life. Wow, that got interesting and philosophical. But coming to the big question, how can we use this in real life to defy gravity? Do we actually do that, or do we actually notice it somewhere? Well, we have been doing it all this while without knowing it at all. Or, to put it better, the planet we are on has been doing it for a few billion years by now. And if you want to watch it happen, then all you need to do is look up at the night sky. That's right. Have you ever asked yourself why the moon doesn't fall straight into the earth and instead just goes around it? Well, now you have your answer. You see, when we say gravity acts downwards, what we really mean is that it acts towards the center of the earth. So in this example, the moon is like our charger, the earth is a tether point, and the force of gravity acting on the moon is just like our charging cable. And so, of course, if the moon stayed still, then it would fall into the earth. But because it moves, it's able to use this pulling gravity as a tethering gravity and goes around the earth instead. In fact, this is the same reason why planets go around the sun as well. So look at that, ladies and gentlemen. We just learned a lot about astronomical orbits from a charger and its charging cable. Imagination surely is powerful, isn't it? Well, we can actually take that a bit further. Now, if I had a tiny distance between my tethering point and the charger, then I'm sure you'll agree that I have to spin it a little faster to make it spin in the first place. And if I increase this distance, then now I can spin it a little slower. And that is exactly the reason why planets that are farther away from the sun move slower around it. And you can apply the same explanation for satellites that are revolving at different distances around the Earth. And there you have it, ladies and gentlemen. A simple home experiment to show you how planets and satellites have been tricking gravity for billions of years. If you'd like to know more about orbits and the way planetary bodies move, then please drop your questions in the comments below. Until next time, I'm Varun from OK But Why. Stay safe, stay curious, and stay tuned for the next video.